All right, so here is, let's get everything going. Double check on sound. I think that's the right sound. And that should work fine. All right, so new project after green sheet is the mini train project. This project is going to end with an assembly, which is what this is. It's a, why is my, yeah, there we go. An assembly of all of the parts. The drawings for the parts, the technical drawings are on the spreadsheet calendar called Mini Train Drawings. And you can use the dimensions from that. If you need a hard copy printed out, which I could see that being useful for some people, if you really want it, I can make that happen also. But we'll be doing walkthroughs for the parts in the same manner that we're doing the green sheet parts, which, but we're not going to do them completely in order because I don't think it makes sense. Some of them are pretty complicated, like the cow catcher on the front is one of the harder things that you'll do. It requires a loft and a shell, which are part features we haven't done yet, but that's why we're here. We're learning. And then there are super easy ones like the hitch magnet. It should take you about 15 seconds to do. It's a circle, an extrusion, a circle, and a cut extrusion. And that's about as long as it should take. But the ones we're going to start with today are, there are 3 different pegs. There's hitch peg, linkage peg, and axle peg. And the way we will do these is we're actually going to use the revolve tool. Actually, this first this first demo is going to be just hitch peg, which is part number 4, and linkage peg. And they're very similar, even though obviously dimensions are different. Because if the dimensions were the same, they'd be the same. But the way that they're made is we're going to use the revolve tool. And the revolve tool is sort of like the extrusion tool, except the shape, the sketch that you make is sort of this cross section here. And if you make this cross section and instead of extruding it in a straight line, you do a revolve around whatever you want the center axis to be, and it creates material going around like that. Okay, we will start with, let's start with hitch peg, which is part number 4. And so we need to come up with the dimensions of, we'll start, whenever you're doing a revolve, your best bet is to start with whatever you think the center axis is going to be. And in this case, the center axis is this vertical line that is 0.65 inches tall. And so for all of this, we're going to do a default part file, which is from the little drop down there. And just like any other part, we'll start with a sketch and we start with the XY plane. But just to see where we're going, before we put any dimensions, if I just make this general shape right here, just with lines, if I just go something like this, obviously this is not close, but if I make that shape and do finish sketch and revolve, it will choose that shape, but then I do have to choose what I want it to spin around. And if I choose that, it will create material sort of doubled, what ends up being doubled left to right, just because it is spinning around that axis. So the slight complication of using the revolve is that all of the dimensions are going to be doubled left to right, assuming you're revolving around that vertical axis. But it will make sense as we go. All right, so we are going to use the line tool, except for this arc part, which will make the rounded over top or head of the peg. But like I said, we'll always start with whatever this vertical line is. That's going to end up being our center axis. We'll put that in the center of the sketch right there. And we just need a vertical line that's 0.65 tall. So we'll get the line tool from 0, 0, go straight up and dimension that 0.65. Zoom to fit. Okay, and we're going to work our way around. So we have this. Now we need this line. So the dimension we're given for the base is 1/4 inch, but that's 1/4 inch all the way across. We just want this line, which is 1/8 of an inch. So from what, if the dimension we're given is the full diameter of what it's going to be when it's rounded over, we are only drawing the radius, which in this case is 1/2 of a quarter or 1/8 or 0.125. And if you forget to do this when you do the revolve, it will look very much wrong. So then we need this vertical line. Again, we're working our way around. This vertical line is just 0.5. From here, going straight up, make sure you snap it to vertical. And I'm going to put the dimension over here. You'll see why in a second, 0.5. And that's because we have some other drawings to do over here. Now, the next part, working our way around, we need this little line here, but we are not given the dimension of that line. What we're given is the diameter of the peg at its widest part. We know the diameter of the peg is 0.4 all the way across at its widest part. So that means the distance from our center axis to the widest point is 0.2. This is the dimension we have from here to here, and that's fine. That's the dimension we'll use. We don't actually, I mean, you could do the subtraction and figure out the length of this little part, but we don't need to know. We are just going to make the line and then dimension the distance from the end point of that line to the center and make that 0.2. So we can get the line tool from here, just go out horizontally and in dimension. We know the distance from the center axis to that point needs to be 0.2. And then the only other part of this sketch is this arc, which we are going to use an actual arc. And there's a couple types of arcs, but we're going to use 3-point arc, which is the default version. And 3-point just means there are 3 clicks where the arc starts, where the arc finishes, and how archy it is. Now, the radius, the dimension that we want, SR, spherical radius, is 0.208. And here's the thing, though, when you do that 3rd click, if I have it going the wrong direction and then type in 0.208, which it somehow snapped to, it won't change it. If I do a 3-point arc, 1st click, 2nd click, and then have the 3rd click past halfway, if I put in the dimension 0.208, that's clearly wrong. So the trick for arcs is you kind of have to make it look pretty close to correct before you put the dimension in. Dimension 0.208. And then we have a closed sketch. You can see down here it says fully constrained. We can do finish sketch. And instead of doing extrude, which this is what an extrusion would look like, we're going to do revolve. There's only one closed loop, so we don't have to select the profile, just like when you do an extrusion, your first extrusion, it knows what you want to extrude. It knows what we want to revolve. We just need to choose the axis, and the axis we want to spin around is this one. If we spin around this one, it will make that shape, a completely different shape, but still using the same tool. We want to revolve around that first line that we drew, which is this one, and it will make that shape. And you can see how those dimensions translate into the full part, why you need to do half for anything that's left to right. And that is called hitch peg, part number 4. Okay, and let's go ahead and do let's do linkage peg. And if you want to see where these all fit together, hitch peg is used back here. That's hitch peg. And linkage peg connects the linkage arm. Just in case it wasn't clear, anytime you have in this assembly, we're going to end up having 4 wheels. Makes sense. You only need to make one part file of the wheel. You don't need to make the wheel 4 different times. I think most people would infer that, but some people don't, and just save you the hassle of repeating things. But you do need to make them all at least once. So the next one we're going to do is linkage peg, which uses the same concept of a revolve, where we're going to start with the center axis and we will work our way around. And this one actually is missing a dimension. It's disappointing, but there's no, remember on the last one that we just did, there was 0.4 was the distance all the way across at the widest point. That dimension doesn't exist. We can kind of eyeball it, which I hate to do, but it's a situation. But everything else works out the same way. So let's start a new part file, default size, start a sketch on the XY plane. We are always going to start with our vertical line down the center. And the height of that is 0.325. Dimension 0.325, zoom to fit. And then we're working our way around, make a line dimension, line dimension, line dimension. Okay, we have this, we need this. We know that the diameter at its widest point at the bottom is 0.0625. So the length of this line is half of that. And so we can do a line here and dimension. And you can do the math point, or you can just have Inventor do the math 0.0625/2. You can put simple arithmetic in the dimensions, the dimensioning text input dialog box. I don't know. And it will do it for you. The next line we know from that endpoint straight up. And the length of this line is 0.25 tall. So let's go ahead and dimension that to 0.25. Then we have that line that goes out here that we don't know the dimension of, but we'll sort of figure it out once we do the revolve. We can actually go back and edit it to make it look right by changing the part that sticks out. But the last part in order to close this loop is our 3-point arc. First click, second click, make sure you're getting that green snap because we want it to be a closed loop, and then slightly curved in the right direction. And the dimension SR, spherical radius, but we can just translate it into regular radius of this arc. Remember, arcs are dimensioned by their radius and circles are dimensioned by their diameter, which, obviously are directly correlated, but it makes sense. And we want, what was it? I already forgot. 0.1562. Okay, and then we will be able to revolve this. But if we can drag this line out, which will change the shape, but you'll see if you go out too far, if it goes up before it goes out, it will make a weird shape. And I'm going to do this wrong on purpose for now. We'll do a revolve. We know it knows what loop we want to revolve. We just have to choose the center axis. And if I hit OK, you'll see there's a tiny little dimple in the top. Actually, it's kind of difficult to see. It's pretty close. If you do something wrong, make sure you're editing the sketch. All of these parts, well, the first two that we do, are going to be a single sketch turned into a single revolution. And we can go back and edit the sketch. I don't know why I popped that way, but if we make this line too long, there will be a dimple there. And if you change, if we edit the feature and instead of going 360 degrees, let's say we go 340 degrees, you're able to see how that sketch translates into the revolve, where if it goes up before it goes back down, it leaves that dimple. So we are going to edit that sketch so that it is like about there. And I bet it's a nice clean dimension that they just forgot to put on there. What if I do, what did they have there? 0.1562. Is that right? Yeah, I wouldn't be surprised if the intended dimension was the same as the radius. That would make it a perfect arc or a regular arc. And let's go ahead and make it 360 degrees again. Edit feature. 360 like that. Okay, and there you go. That's linkage peg. And I'm going to go ahead and do all 3 pegs in this one recording. The last peg is axle peg. Now, the way that the drawing shows it is not in a revolve, but we are going to infer the revolve based on these dimensions. And it does actually get kind of complicated, but we'll figure it out. A couple things you need to know, and really by know I mean ignore for now, is this set of dimensions down here, hex socket, 5/30 seconds across flats, 0.111 deep. That just has to do with this shape here. And the extrusion for the hex wrench or Allen key that would be used for it. The dimension over here, 1/4 20 UNC by 1/4 inch offset, that has to do with the threading that you can put on there, not very difficult. This dimension over here, 45 degrees by 0.03, has to do with this chamfer, which is the rounded over, or excuse me, not rounded over, knocked off edge at the bottom that makes it sort of slanted. The rest, we're just going to work around it and make the sketch so that we can do a revolve for most of the part feature before we do these other new things. So we're looking for a sketch that looks something like this. Okay, there's going to be a tiny vertical part that we haven't seen before on the other 2 pegs that will make that. And there's going to be a horizontal part at the top, which will make, when it's revolved, will make this flat surface on the top. So stick with me and we'll do a new part file. And just as per usual, we're going to start with a vertical line. And the vertical line is the total height, which you need to combine the length here is 1, which you can tell from this threaded part, but you just need to know that, plus the height of the head. The height of the head is 0.125. So our first vertical line is going to be 1.125, which I don't really expect you to be able to have figured that out on your own, which is why we're doing this. Okay, then we're going to have a line that goes across the bottom this way. And we know that the threaded part of the bolt or peg is 1/4 inch across. And so we need a line that is a 1/8 of an inch, because remember, anything horizontal gets doubled. So the dimension we put in needs to be halved so that when it is doubled, it's the correct one. So we need 1/8 of an inch across the bottom, 0.125. Then we have a vertical line, which is the length of not the threads, but the cylindrical part of it, of the bolt, which is 1. Okay, and then we need to work our way around where we are going to have a line that comes out. So we have this, this, and this. We're going to need a line that goes here to make, the head just the way the other part has. And then this flat part is going to be made with a small vertical line. This flat horizontal part is going to be made with a short vertical line. And then we'll have a 3-point arc, just like before, connecting them. First, the length of this line is like on hitch peg, where we don't know the length, but we do know its distance all the way across the widest point. And the distance all the way across the widest point is 0.422. That's its width there, but we are just drawing from the center out, so we want 0.211. So we need a line that goes from here out. But again, we're not dimensioning the length of this line. We're dimensioning the distance from the center to the end of the line. That's 0.211. Then our vertical line, to make that vertical face, is 0.031. Line. Make sure that it snaps to vertical, and dimension 0.031. Okay, if we were working our way around, we would do our arc next, but we don't have the place where the other side of the arc connects to. So we're going to draw this line here and then connect our arc. Okay, so this line here relates to the size of the flat part here. Okay, it says it's a 1/4 inch all the way across, 1/4 inch diameter across the flat, but we only want the radius, so it's 0.125 from the center out. Line that goes from here this way, dimension 0.125. Then the last part of our sketch, before we do the revolve, we're going to do the other part features we're going to do them as other part features, even though like the chamfer we could do before the revolve, but like chamfer and fillet are both part features and sketch features, but it works better if we do it after the revolve. Regardless, the 3-point arc is 0.236 in radius, so we'll get an arc that connects green point to green point, and dimension that 0.236. We'll finish sketch and revolve. We just need to choose the line we want to revolve around, which was our first tall vertical line. Hit OK. And there are, I think, 3 other part features. Let's just do the chamfer at the bottom. The chamfer at 45 degrees, which means that it's just knocked off the same amount in both directions. You'll see there's 3 types of chamfers. We're just going to do the basic one. And the dimension is 0.03. So the chamfer tool is right here. First, we need to choose what edge we want to round over, which is this one. And the dimension we want is 0.03. And because it's the first type, which is the same distance in both directions, that will leave it with a 45-degree angle. There is distance in an angle, which you type in 0.03 angle 45, but you do need to choose which face you're working from, which is that one. And that would do the same thing. And well, either way, it works. And that's how you get that rounded over portion. Let's do the hex hole in the top. The hexagon hole in the top is 5/32 across flats. Okay. And hold on a second. Okay, and I've already broken my microphone. Let's try again. All right, the 5 30-seconds across flats, we're just going to use the basic hexagon tool, or technically it's polygon, and you choose 6 as the sides. Start a sketch just like we were doing some sort of cutaway on that top surface. And the tool we want is polygon. It's a in the drop down for rectangle. And we want 6 sides, and it's just like drawing a circle where you snap to the center and move out to set it. And those are all constraints. They want everything to be perpendicular and whatever. The dimension we have is distance across flats, meaning the distance from this line to this line should be 5/32. And we're going to finish sketch, extrude, choose the center, switch it to cut extrude, and the distance that we need to cut, if you look at the dimensions, 0.111. Hit OK. And the only other thing that we have to do is the threads, which it's not actually threads as in like making faces for the spiral part of whatever. It's really just sort of like a picture of threads. And regardless, we use the thread tool. First, when you choose the face, and don't worry about, well, 20 UNC is the default. We want what is the depth? Let's see what 0.25 offset 0.25. There we go. And it says 0.97 instead of 1 inch, and that's because we have a 0.3 chamfer at the end, and that's fine. The key is this 20.25 offset, which is how you get the not threaded portion there, and hit OK. And that is axle peg. You should, when you're saving all of these, unless you are doing folders, which is fine as long as you're consistent. If you're just saving everything into documents, give them file names that start with the same, like you could just call it mini train axle peg, axle peg, and that way they will all show up alphabetically in the same place. It'll be a lot easier to find them. If you want to call them train and then the file name, that's fine too. Just, it's about organizing. Having good file management techniques is super important as you move forward, and now is a great time to practice them. But that is where we're going to end this recording. So you can start with those. You should all probably be able to do hitch magnet without even trying, and maybe even linkage arm. We'll do a recording of just the super easy ones together, but that's where we're going to end this. And I'll put up a recording as soon as